Hello, I'm Jan Trower, and today I'll be speaking of the elaborate sport of Jiu Jitsu. Brazilian Jiu-Jitsu is a world-renowned martial art involving taking your opponent to the ground, controlling them using gravity and center of mass to your advantage, and ultimately making your opponent submit to the fight, usually using a locking of a limb or choking. In Jiu Jitsu, the main physics components utilized are force, leverage, torque, angular momentum, and center of mass. Jiu Jitsu is an entirely technique-reliant sport which encourages the fighter to maximize efficiency of these components of physics to their own advantage. Today, I'll be speaking upon the brief physics behind Jiu-Jitsu while utilizing and demonstrating two arm locks. I'll be talking about the arm bar and the Americana, two very force-efficient arm locks which use torque and leverage. Let's begin with the Americana, a move that can be done from side control on the ground or while on mount. The secret behind a successful Americana is the proper utilization of torque, an angular version of force, and a turning effectiveness of a force. Torque deals on many occasions with hinges of sorts. In this scenario, the opponent's shoulder is the hinge we'll be trying to overturn. The equation for torque is T equals rFsinθ, T representing the turning effectiveness of a force, R representing the radius of rotation, and F representing the magnitude of the linear force. Theta is the angle that lays in between the radius and the applied force. The units for torque and are newtons meters. While pinning my opponent's left wrist to the ground with my left hand, I'll place my right hand under his arm and will connect my left wrist while positioning his arm flat at a 90-degree angle. Maintaining his wrist pin while moving his elbow and the rest of his arm will create tension and pull his shoulder and its muscles. The longer the opponent's humerus, the higher the torque due to the longer the radius of rotation. The armbar is a powerful arm lock executed by placing your opponent's arm between your legs, creating a lever-like mechanism that can be used to break the arm. Leverage is simply the ratio of the output force to the input force, which produces the mechanical advantage of the lever. Levers are meant to amplify the input force to result in a stronger output force. The lever arm is measured as a distance. The units of the lever arm's magnitude is always stated in the units of meters. In this case, R is the length from the middle of the elbow to the wrist. The opponent's arm is treated as a lever, with your elbow hinge being the fulcrum of the lever resting on your waist. A detail behind the armbar is the fact that the closer you grab to the opponent's wrist, the longer the depth of the lever becomes, which according to the equation T equals rFsinθ means we could have a higher torque and increased mechanical advantage. The longer your opponent's forearm, the longer the radius of rotation for a higher potential mechanical advantage. The longer the radius of rotation, the higher the torque will be, whereas if we had the same force applied but less radius of rotation, we would have less torque, which is highly noticeable when doing the submission. Now that you know the equation for torque, let's go over a unique problem I've created. Let's suppose the length of a person's forearm is 0.25 meters. The amount of torque required to break your elbow joint is 5 Newton per meter. How much force must one apply to break an opponent's arm?